Hello and welcome everybody to another episode of Books and Bytes. Today, we're diving into a book that sparked a revolution, Benjamin Franklin's experiments and observations on electricity.
It's amazing to think how much of our modern world comes from the ideas in this book. It's a collection of letters Franklin wrote between 1747 and 1750, sharing his experiments and theories about this mysterious force.
And you know me, I love a good historical deep dive, especially when it involves a founding father and groundbreaking science. So what are we in for with this one?
Well, you'll see Franklin's brilliance unfold as he grapples with the very nature of electricity. He goes beyond simply observing its effects. He wants to understand what it as, and in doing so, he develops concepts like positive and negative charges, explores the storage and discharge of electricity with the Leyden jar, and even makes the connection between his experiments and the natural phenomenon of lightning.
Okay, so we've got groundbreaking experiments, a dash of danger, and the birth of inventions that changed the world. I'm hooked already. Where do we even begin?
The book itself is structured as a series of letters, starting with Franklin's early fascination with what he calls electrical fire. He describes it as a subtle, invisible fluid that can be excited, collected, and even stored. It's this concept of electrical fire that underpins a lot of his early experiments.
You know, it's interesting how he uses this term electrical fire. It seems almost poetic,
Yeah.
but it also speaks to the limited understanding of electricity at the time. They knew it could generate heat and light, but its true nature was still a mystery.
Exactly. And you see Franklin wrestling with that mystery throughout these letters. He's constantly observing, experimenting, and refining his ideas as he goes. One of the first big puzzles he tackles is the Leyden jar, this fascinating device that could store electrical charge.
Okay, the Leyden jar. I remember reading about this in school. Wasn't it one of the earliest forms of a capacitor?
That's right. It was basically a glass jar with metal foil lining the inside and outside. You could charge it up, and then, well, let's just say touching it led to a rather shocking experience.
Literally shocking. Right. I bet those early demonstrations got people's attention. But beyond the spectacle, what was Franklin really trying to understand with the Leyden jar?
He was intrigued by the concept of electrical equilibrium, this idea that electricity seeks balance. He compares the Leyden jar to a bottle with compressed air on one side and a vacuum on the other. The pressure wants to equalize, but it can't do that within the bottle itself. You have to create a path for the air to flow out and back in.
So he's seeing a parallel between the flow of air and the flow of electricity.
Exactly, and this is a key insight. He realizes that the same principle applies to electricity. When you charge a Leyden jar, you're essentially creating an imbalance of electrical fire, what we now call positive and negative charges. And that imbalance can only be resolved by creating a path for the electrical fire to flow externally, causing that shocking discharge.
Okay, that makes sense. But how did he actually figure this out? Did he just keep shocking himself until the answer became clear?
Well, maybe not intentionally, but his experiments with the Leyden jar are incredibly detailed and insightful. One experiment involved suspending a cork ball near the charged jar. He found that the ball was repelled when brought near the wire at the top, but attracted when moved towards the bottom.
So the same object was both repelled and attracted by the same jar. That's pretty counterintuitive.
It was, and this led him to a crucial realization. The electrical fire wasn't just on the surface of the jar, it was distributed throughout its substance. He uses the analogy of a linen thread being drawn to the bottle to illustrate this. The thread wasn't just attracted to the metal parts, it was drawn to the glass itself, suggesting the charge was somehow embedded within it.
That's a pretty big leap, going from a cork ball on a thread to understanding how the charge is distributed within the jar. But it highlights something I admire about Franklin: his ability to connect seemingly simple observations to deeper principles.
Absolutely, and that's where his genius really shines. He's not just documenting his experiments, he's actively trying to make sense of what he's seeing, building a coherent framework for understanding electricity. And this leads him to another key concept, the idea of positive and negative charges.
Right, we touched on that earlier. He moves beyond just talking about electrical fire and starts to distinguish between different types of charge.
Exactly. He realizes that charging a Leyden jar isn't about creating more electrical fire, but rather about separating it, pushing some to one side, leaving a deficiency on the other. He starts using the terms plus and minus to describe these states, essentially laying the foundation for our modern understanding of positive and negative charges.
So he's literally creating the vocabulary we use to talk about electricity today. And he's doing it all through these meticulously documented experiments.
And his writing is surprisingly engaging for a scientific text. He even throws in some humor now and then, like when he describes his plan for an electrical feast on the Schuylkill River.
An electrical feast. Now that sounds intriguing. Tell me more about that.
Well, it was more of a whimsical thought experiment than a practical plan, but he describes how spirits would be ignited by sparks sent across the water, a turkey cooked on an electrical jack, and toasts made with electrified bumpers.
It sounds like a party straight out of science fiction novel.
Hmm.
But it also shows how his mind was constantly buzzing with ideas about how to harness this newfound power.
And his curiosity doesn't start with the Leyden jar. He starts exploring other ways to manipulate electrical fire, leading him to one of his most famous discoveries, the power of points.
The idea, the power of points. This is where things start to get really interesting. And I think it's a perfect place to pick up in part 2 of our deep dive.
I agree. We'll delve into how this seemingly simple observation about pointed objects leads to some of Franklin's most groundbreaking inventions, and ultimately changes our understanding of the natural world. Well, welcome back to our exploration of Benjamin Franklin's experiments and observations on electricity. Before we jumped into the break, we were talking about Franklin's expanding understanding of electrical charges and his almost playful vision of an electrical feast.
It's amazing to see his mind at work, isn't it? He's not just content with observing these phenomena. He's actively trying to figure out how to control and manipulate them. And that leads us to the power of points, which you mentioned earlier.
Yes, this is where his experiments take a turn towards the practical, with implications that reach far beyond the laboratory. You see, Franklin noticed that pointed objects seemed to interact with electrical fire in a unique way. They could both draw it in and throw it off more effectively than blunt objects.
Okay, I'm picturing a metal sphere versus a sharp needle. Why would the shape matter so much when it comes to electricity?
That's exactly the question Franklin grappled with. He describes an experiment where he uses a sharp needle to neutralize the repelling force between a charged iron shot and a cork ball. The needle essentially disarms the electrical charge.
So it's not that the needle is destroying the electricity, but rather redirecting it somehow.
Precisely. He theorizes that the pointed shape allows the electrical fire to concentrate at the tip, creating a sort of pathway for it to flow in or out more readily. Think of it like a lightning rod, though of course he hasn't invented that yet.
Ah, but that's where this is all leading, isn't it?
Yeah.
This understanding of points in electrical flow lays the groundwork for his most famous invention. But before we get to the lightning rod, let's back up a bit. How does Franklin even make the leap from these small-scale experiments with needles and cork balls to thinking about something as grand and powerful as lightning?
It's a testament to his observational skills and his ability to connect seemingly disparate ideas. He starts paying close attention to the similarities between the sparks he's creating in his lab and the lightning he sees in nature.
So he's noticing parallels in their behavior, the light, the sound, the way they can melt metal.
Exactly. He meticulously lists these similarities in his letters, arguing that lightning is simply a massive electrical spark, not some supernatural phenomenon. And this leads to one of the most iconic moments in scientific history, the kite experiment.
Oh, this is the one everyone's heard of. The story of Franklin flying a kite in a thunderstorm trying to capture lightning. But is there any truth to that tale? Wasn't it considered incredibly dangerous?
There's strong evidence to suggest the experiment did take place, though accounts vary in their details. And yes, it was a risky undertaking, but Franklin understood the danger and took precautions. He wasn't holding the kite string directly. He used a silk ribbon, which would stay dry and act as an insulator, and he attached a key to the end of the string, realizing that metal would attract the electrical charge.
So he was essentially creating a path for the lightning to follow down the kite string and into the key. And then what?
He describes how as a thundercloud approached, the loose threads on the kite string stood on end, just like the hairs on his arm would when he was near a charged object. And then when he brought his knuckle close to the key, there it was, a spark.
He literally pulled lightning from the sky. I can only imagine the thrill of that moment, the realization that he was right, that lightning was indeed electrical in nature. It's like something out of a superhero comic book.
It's a defining moment not just for Franklin, but for our understanding of electricity. And it's this experiment, along with his observations about the power of points, that leads directly to the invention of the lightning rod.
Okay, so how does he make that connection? How does he go from a kite in a thunderstorm to a device that can protect buildings from lightning strikes?
He realizes that the pointed wire on his kite was essentially attracting the lightning, acting as a conduit for it to flow down the string. So he reasons that if you attach a similar pointed rod to the top of a building and connect it to the ground with a wire, you could provide a safe path for the lightning to follow.
So instead of striking the building and causing damage, The lightning would be intercepted by the rod and channeled harmlessly into the earth.
Exactly. And this, of course, is the lightning rod as we know it today, an invention that has saved countless lives and structures from the destructive power of lightning.
It's incredible to think that this simple yet ingenious device is a direct result of Franklin's curiosity, his willingness to experiment, and his ability to connect the dots between seemingly unrelated phenomena.
And his insights don't stop there. He continues to explore the nature of electricity, even questioning some of his own earlier assumptions.
Like, well, I thought he pretty much had it all figured out by this point.
Well, one thing that bothered him was this. If glass is such a good insulator preventing the flow of electricity, how is it possible for a Leyden jar which is made of glass to hold a charge at all?
That is a bit of a head-scratcher. If the glass blocks the flow, how does the electrical fire even get inside the jar in the first place?
He wrestles with this paradox and ultimately concludes that the electrical fire must somehow be stored within the glass itself. He imagines that the glass is like a sponge that's already saturated with water. It can't absorb anymore, but you can squeeze some out of one side and have it re-enter on the other.
So he's envisioning the glass as a container that's already full of electricity. And charging the latent jar is about redistributing that charge, pushing some of it to one side, and creating an imbalance.
Precisely. And this leads to some even more mind-bending ideas, like his speculation that electrical fire might be essential to the very nature of glass, that without it, glass might lose its transparency, brittleness, or elasticity.
Wow. He's really pushing the boundaries of scientific thought here.
Yeah.
It's like he's trying to understand the role of electricity, not just in isolated phenomena, but in the fundamental structure of matter.
And that's what makes his work so compelling. He's not just answering questions, he's raising new ones, provoking us to think about the world in a completely different way. And his exploration of electricity continues with even more twists and turns as he delves deeper into its mysteries.
This is truly a deep dive. I can't wait to see what other insights he uncovers in his later experiments. And I'm sure there's still plenty to unpack about his theories and their lasting impact on the world. Shall we continue exploring in part 3?
Absolutely. Let's dive back into the fascinating world of Benjamin Franklin and see what other sparks of genius await us.
Welcome back to Books and Bytes. We're continuing our deep dive into Benjamin Franklin's experiments and observations on electricity.
And it's remarkable how even after achieving breakthroughs like the lightning rod, Franklin doesn't stop questioning and refining his understanding.
Exactly. We left off discussing his theory that glass itself could store electrical fire. It sounds counterintuitive, considering glass is such a good insulator.
It puzzled him, too. But his experiments with the Leyden jar led him to this conclusion. He even tried removing the water and metal parts from a charged jar and found that the glass still retained the charge. This suggested to him that the electrical fire wasn't just residing in the metal or water, but somehow permeating the glass itself.
So he was envisioning electricity as something that could exist within the very structure of matter, not just on the surface.
Precisely. And this wasn't just a theoretical curiosity for him. He speculated that this inherent electrical fire might be crucial to the properties of glass itself, like its transparency and brittleness. It's a fascinating concept that foreshadows our modern understanding of how atomic structure influences a material's properties.
It's incredible how he was grappling with these ideas centuries before we had the tools to confirm them at the atomic level. But his inquiries didn't stop there, did they?
Not at all. He continued to investigate the nature of electrical fire, conducting experiments with different materials to see how they interacted with the charge. He even tried combining electrical fire with other substances, like cinnamon, to see if he could imbue it with different properties.
Electrified cinnamon. Now that sounds like something out of a fantasy novel. What was he hoping to achieve with that?
Well, it speaks to his playful curiosity and his desire to explore every facet of this new force. He wondered if the electrical fire could carry with it the properties of the substances it passed through, perhaps creating a shock that doubled as a spicy sensation, or even a laxative.
I'm guessing those particular experiments didn't pan out as he expected?
They didn't. He concludes that the electrical fire seemed to retain its own unique characteristics, regardless of what it traveled through. But even these seemingly failed experiments contributed to the growing body of knowledge about electricity, demonstrating its consistent behavior across various materials.
It's a reminder that even the most brilliant minds encounter unexpected results in their pursuits. But Franklin's dedication to meticulously documenting his findings, successes and setbacks alike, is truly admirable.
It speaks to his commitment to the scientific process and his belief that every observation, no matter how puzzling, can add to our understanding of the world.
And it's not just about theoretical understanding for Franklin, is it? He's always looking for practical applications, ways to make these discoveries useful to society. We've already discussed the lightning rod. But what other practical inventions did he envision?
He believed that electricity had the potential to revolutionize many aspects of life. He even explored using electrical shocks to kill animals, believing it could offer a more humane method of slaughter, compared to traditional techniques.
That's certainly a less whimsical application than the electrified cinnamon or the electrical feast we talked about earlier. But it shows his pragmatic side
Hmm.
and his willingness to explore even the less glamorous possibilities of this new force.
Exactly. He saw electricity not just as a curiosity, but as a powerful tool with the potential to improve everyday life. And his methodical approach, his clear explanations, and his infectious enthusiasm for discovery continue to inspire scientists and inventors to this day.
So as we wrap up our deep dive into Benjamin Franklin's experiments and observations on electricity, what are some key takeaways you hope our listeners will remember?
I think it's crucial to recognize Franklin's relentless curiosity and his dedication to unraveling the mysteries of the natural world. His approach to science, the careful observation, the meticulous experimentation, the willingness to challenge assumptions is something we can all learn from.
And it's inspiring to see how his work laid the foundation for so many technological advancements that we take for granted today. From the lightning rod that protects our homes to the understanding of electrical circuits that powers our devices. His legacy is all around us.
And perhaps the most important takeaway is the reminder that scientific discovery is a journey, not a destination. Franklin's letters show us that even the most groundbreaking insights are often the result of years of exploration, setbacks, and revisions. It's about the process of asking questions, testing ideas, and continually refining our understanding.
It's been an electrifying exploration, to say the least. Thanks for joining us on this journey through Franklin's world of electrical wonder.
It's been a pleasure diving into this fascinating book with you, and who knows what other scientific adventures await us in future episodes of Books and Bytes.